is Bio 181, Chapter 13 on human genetics, and we're going to dive deep into, well, as deep as we're going to go in this class, pedigree charts. So, pedigree chart, we're representing inheritance patterns. Females are represented with circles, males are represented with a square. These would be unaffected. And if you are affected with the trait of interest, then shaded in. So a female affected and a male affected here. All right. So for example, if you have a parent, let's say mom and dad, and they have offspring, then you're going to connect the mom and dad with the line, or the two parents. And then the offspring are going to be down a little ways. That'll be the next generation. And so on this next level, that's where you're going to put the offspring. So let's say they have two girls and one boy. Okay. And maybe one of the girls then has two boys. So you've got three generations here, the parental generation, your first filial generation, and your second generation. Or the parents, you can think of them as grandparents, parents, and grandkids. So if we have a dominant trait represented here with the female, let's just say capital A, and we cross that with a recessive trait over here, lowercase a, lowercase a. So these are both homozygous. Then the offspring, if we think about the Punnett square, let's draw it over here, you think about the possibilities with capital A for the mom, lowercase a for the dad. These are all identical. So all of the children are going to be homozygous for the trait, and they're all going to express the trait since it's dominant. So these would all be shaded, right, in this example here. Okay. And then for this one, this woman, the grandchild down here, would need to have fertilization of her eggs to get the offspring. So I'm just going to say, so here's an outside member from the family, a male comes in here. So then maybe this male, well, let's just say again, recessive. Okay. Then we would have the same outcome for the next generation. And so we would draw that as shaded. All right. So you can then solve problems with pedigree by working backwards sometimes. The easiest way, if it's a pure dominant or recessive trait, so we're talking about pure Mendelian genetics, where we're not talking about incomplete dominance or codominance, anything like that. And we're going to assume capital A is dominant, lowercase a is recessive. And then you could have a question like this. So the easiest place to start is, you know, that if you have two lowercase a's, that is homozygous recessive. And that means that they are going to express the recessive trait, right? So it's the expressive, it's the phenotype. So this is going to be all of the unshaded circles and all of the unshaded squares are going to be homozygous recessive. So you could just go in and fill all those in right away for all of the options. That's easy. Okay. All right. Then we can go back and kind of work backwards and think about some of the others. So if I start over here with, well, looking at these offspring, so, and you can't see me, so I'm actually looking at number 6, number 7, and number 8. So these are all homozygous recessive. That means they had to receive one of the lowercase a's from the mom, and then the other one would have come from the dad, okay, for each one. So that means the dad had to have at least one lowercase a or recessive allele. The phenotype is the dominant since it's shaded. So that means the other one is dominant. So the dad is heterozygous. So you figured that one out. Okay, and then you can kind of work similarly. I'll go over here and look at 13 and 14. So for 14, we also have homozygous recessive. And so again, same scenario. If you work backwards, you know that one of the recessive alleles came from the dad in this case, and then the other recessive allele would have had to come from the other parent. So you know that this parent is also heterozygous. Okay? And then for the offspring here, you know that since they are shaded, they're expressing a dominant phenotype. So they have a capital A. And then from the father, they could only receive a recessive allele. So you know that they're also heterozygous. So similarly, you could work out the rest of this example. All right, that's it for this video.